In the very last year, we have performed a lot of job in order to make IoT devices easier and safer to be used. The two main objectives we had worked on are radiation protection performances of the device and treatment planning system for an IoT machine. Why radiation protection? Because radiation protection plays a crucial role for IoT feasibility. The lesser the amount of stray radiation produced, the more the number of patients that can be treated, the safer everybody feels. And this is important. This development required, let's say, a peculiar approach. And if I may say, this is something where we are particularly good. Not to try to imitate other technologies, but focus on the specific issue, the specific challenge of our work, and look for specific solutions. And the other crucial aspect for IoT, in my humble opinion, what was missing was the possibility of planning IoT. Not only pre-planning using preoperative images, but especially planning after the surgeon has made his or her own job and use operative images so that becomes possible to plan the treatment on the real volume to be irradiated and properly select all the irradiation parameters. Within this framework, I would say that the solution we have implemented has got all the relevant pillars, offer the possibility of using 3D images taken during the intervention, offers the possibility of virtual planning the treatment, and then guides the correct positioning of the applicator on the volume to be irradiated. So, as all the part needed for assuring a proper planning and execution of the treatment. FLASH is an extraordinary promise, and it's also an unmatched challenge from a technological point of view. First point is a research machine. A research machine is needed in order to allow the scientific community to precisely determine flash effect. This is crucial, and what's important from the LINAC manufacturer point of view is to provide a technology reliable that allow the researcher to do their work without worrying on the reliability of the LINAC. A successful research, a successful radiobiological research in FLASH requires a very reliable FLASH research LINAC. And how this research LINAC should be? Well, it should be as reliable as a clinical one. Otherwise, it would be pretty difficult to gather all the robust data needed for the community. And what does it mean? It means that it must be designed according to the medical standards. That for electron LINACs is the 60601-2-1 technical requirement for LINAC. So it means real-time monitoring of the dose and additionally also real-time monitoring of the energy, because in order to reach the flash dose rate, we need to accelerate a significant higher quantity of beam current respect to standard radiation therapy machine. And this implies new and unexplored challenges. The previous work the previous experience that we have gathered along the years with the IRT machine, let's say, helped us a little bit just to have a mind as broad as possible. And then some crucial aspects for IRT are common to the requirement of a flash LINAC. That is, control the current, avoid any possible scattering between the electron beam and S.I.T material in order to reduce Bremsstrahlung and avoid X-ray production. This is one point. And the other point is that the standard technology adopted for monitoring the beam in radiation therapy, that is, monitor chambers, are no longer a solution in flash research. And new technological solutions and new approaches must be found. So all this has been implemented in our system Electron Flash. And we are very eager to provide this tool to the scientific community. Last but not least, it is also important for a research machine to offer a very broad range of dose rate that can be changed, even significantly higher than what will be the probable clinical dose rate. But we have to have a wide and clear picture of the phenomena before we can move to clinical application. The previous experience gained by S.I.T in IRT field prepared us to face the new exciting and unexpected challenges of a flash LINAC. First of all, in the field of accelerating a high amount of current, and then a flash research machine poses new challenges for the design and the manufacture of a dedicated LINAC. First, accelerate a huge amount of current, then real-time monitor it through a proper device and avoid any unwanted scattering between such electron beam and any S.I.T material that would cause a lot of X-ray production. Let's say that S.I.T staff was in a certain manner prepared to face this challenge thanks to the previous experience gained in the IRT field. Thanks to this, we were capable of proposing new solutions that are not the standard one adopted in the radiation therapy machine, especially for monitoring real-time the beam. And this represents a crucial part because the research machine must be as precise as a clinical machine in order to get correct results. There is another aspect that I would like to stress. Electron Flash has been designed in order to offer a broad range of dose rate reachable, up to several thousand gray per second, more than 10,000 gray per second. This is probably more than what will be used in clinical. But before going to clinic application, it's important that the whole picture is clear, even in a region much significantly larger respect to the one that will be used in clinic.